Tepp's bachelor's degree is in earth science education and her master's degree in geology. She's always been interested in the sun and the relative motions of the planets and the moons that make up our solar system. In 2017, she went to Kentucky with some friends to observe and photograph the last total solar eclipse visible in the USA. And it was a truly amazing, inspiring, and spiritual experience. Welcome.
So how do I get this to show? Yeah. How's this? Can you hear me okay? Okay. How about now? Okay. Thanks, Gary, for setting this up. Good morning, fellow Earthlings. I hope you all enjoyed hearing Cat Stevens sing his song Moon Shadow, which, by the way, was written in 1970. That makes me feel old, and I guess you all have the same reaction to that. But I chose that song because we're all going to be in some part of the moon shadow during the solar eclipse on April 8th. I'd like to know how many people are planning to travel somewhere so that they can be in the path of totality. Well, at least somebody besides me, so that's good. I put together a one-page handout about the eclipse, and that's on the table over there. There's about 20 of them, so there's probably enough for everybody. I wanted to let you know that there's a problem now with counterfeit and fake solar eclipse glasses being sold, and that's according to the American Astronomical Society. So that handout that I put together includes a website that has information on how to make sure your solar eclipse glasses are safe for you to use. The handout also has a list of suggested websites for eclipse info and provides times for the partial eclipse for the Washington, D.C. area. And those times are going to be really close to what you'll experience here. I'll also try to get the handout put in our next newsletter so that people that aren't here can benefit from that information. Yeah, I was just trying to move it over so I'll be closer to the mic. Okay. So if you haven't bought your solar eclipse glasses yet, I wanted to show you what a pair looks like. They should have a silver front, and in the back they're black, and they're pretty cheap, pretty inexpensive. They're not made to last, but they do protect your precious eyesight when you're looking at the partial eclipse. And I know some people have brought in extra eclipse glasses. So there's a few up here for people that haven't purchased them yet. And you really do need them. You can't safely look at the sun during the partial eclipse without them. So it's only 9 days, counting today, until this total solar eclipse occurs. It's going to be a week from tomorrow. It's going to be the most beautiful sight you'll ever see in the sky. That's providing the weather cooperates. So we'll have to keep our fingers crossed that we'll have clear skies. this eclipse is really going to be well attended. Authorities are forecasting because there's more than 31 million people in the US that live within the path of totality. And the path of totality is, I've got to turn this on first. There we go. The path of totality. Whoops, I didn't mean to do that. I'm not sure I'm going the right way. Okay, this is what it looks like. It's this strip that goes across the United States like that. And it actually begins down here in Mexico and then goes through 15 states and through 6 provinces of Canada, and then exits over the Atlantic Ocean. So it actually the path starts in the Pacific Ocean and ends in the Atlantic Ocean. And here's Washington, D.C. right here. Let's see. Oh, pressing the wrong thing. This red cross represents Washington, D.C. And on this map, there are contours. This is the 90% contour that Washington is close to being on. That means that if you're on that contour, the moon's going to cover 90% of the sun. And so as you move away in this direction and in that direction, away from the path of totality, the percentage of the sun that's being covered by the moon decreases. So here, 89% of the sun is going to be covered by the moon. So it's going to be pretty spectacular, even if it's not totality. This is the way that an eclipse occurs. Here's the sun, and the moon is between the sun and the earth. Here's the earth. And the earth actually ends up being in the moon's shadow. Right. So there's actually 2 parts to the moon shadow. Probably Cat Stevens didn't know that, but one part is called the umbra, and any area on Earth that's under the umbra part of the moon shadow is going to be having a total eclipse. The other part of the moon shadow is called the penumbra, and it's on either side of the umbra, and areas that are under the penumbra shadow of the moon, those areas have partial eclipses. Here's what the moon shadow looks like on Earth. This was taken by a NASA satellite, and you can see this big black area here. And it's amazing to actually see that from space. Okay, so here's more information about what is actually going on. In order to have a full eclipse, the moon and the sun need to be aligned directly with the Earth. And we'll talk more about that in a minute or two. But as I mentioned, under the umbra on Earth, you have a full total eclipse. And this path here, I'm not nervous, but my hand is shaking because it's hard to hold this thing steady because it's so light. Maybe I should use 2 hands. See if that's better. Yeah. Okay, so this is the path of totality because, the Earth is still rotating and it rotates into the shadow of the moon. And as I said before, if you're under the penumbra shadow, you get a partial eclipse. So there's actually 3 conditions that are needed to have a total solar eclipse occur. First condition is that the moon has to be in the new moon phase so that the sun, moon, and Earth are aligned. The second one is that the moon has to be at or near perigee. And you can see on this diagram here that the moon's orbit around the Earth is not circular. It's actually elliptical. And so at this point, it's closer to the Earth than it is at this point. This point here is called the perigee. So in order for a full solar eclipse to occur, the moon has to be at or near its perigee position. Whoops. The other thing that you should be aware of is that the moon orbits in a different plane than the Earth orbits in. Earth orbits in what is known as the plane of the ecliptic, and this is the same plane that all the planets orbit around the sun in. But the moon's orbital plane is at an angle to the Earth's plane. It's only an angle of 5 degrees, but it's enough to make it so that we only have the potential for a solar eclipse once a year and the potential for a lunar eclipse once a year. So in order for, this is the third condition, in order for a total eclipse to occur, the moon and Earth's orbital planes have to intersect. So this circle right here shows the Earth's orbit, and you can see that the moon's orbit is at an angle to the Earth's orbit. And there's only 2 times a year that these two orbits intersect. And one of those times is the position for the solar eclipse when you have the moon between Earth and the sun. And if the orbits are not at the intersection point, then you can have things like an annular solar eclipse. Okay, and if you're at this intersection point over here, then you have a lunar eclipse because you have the Earth between the moon and the sun. So you need those 3 circumstances before you can have a total solar eclipse. And these are some pictures that were taken of the 2017 total solar eclipse that I was able to see from Kentucky. These aren't my pictures, but I just wanted to go through the sequence with you so you would know what to expect. Before the eclipse starts, the sun looks just like it normally looks. And then over the next hour and a half, the moon will progressively cover parts of the sun until you get to totality, which we're not going to get to here, but you're going to see even more of the sun covered than you see right there, because that's only 75% covered. So we'll be able to get to really near the totality here. And then totality only lasts for several minutes. And then the moon continues crossing over the sun until it gets to the point that the sun is totally exposed. So the whole thing takes about 2.5 hours. And there's part that I'm going to refer to as the pre-totality phase, which is between 75% eclipsed and the total eclipse. And I'll talk about some things that go on during that phase, which you'll all be able to experience. At 75% coverage, like we saw in that last slide, shadows start to get sharper. And from that point, you have about 15 more minutes till you get to totality. If you're near trees, then the leaves of the trees can actually act as pinhole cameras. And you can see many crescent suns appear on the surface. And we wanted to see this, so we set up a table underneath a tree. So this is what it looked like for us. And it was really pretty neat. So have a piece of white paper or something that a white surface you can easily carry under a tree so that you'll be able to see this phenomenon. Also, during this time, the light's going to noticeably fade and it's going to start looking odd and eerie. And it's spooky. It really is, because you start seeing colors that you've never seen before. And the color of the sky and clouds, hopefully there's not going to be any clouds, but if there are, those colors may change. And you'll notice that the temperature starts to drop because, you're going from here, you'll go from 75% to 89% coverage. And that's enough to make the temperature drop noticeably. If you're in a place where it's totality, then the temperature will drop 10 to 15 degrees. So it's a real noticeable drop. This is something that you can do too. This isn't one of my pictures, but you can use this. It looks like a vegetable strainer or steamer, and you can just hold it between you and the sun and have it shine on your piece of white paper, and you'll see all these really nicely formed crescents. And no, yeah, it's indirect. That's right. Yeah, I should just caution everybody during the entire partial eclipse, don't look at the sun unless you've got your solar eclipse glasses on. But looking at the sun indirectly is no problem. The other thing you can do if you don't have a vegetable steamer like this is to just use a colander, and it should look pretty spectacular. So in the final 1 or 2 minutes before totality, the sun is going to be covered 99% by the moon. And these are two of the pictures that I took as you approach totality. And this is like 95% covered. You can just see just a little bit. And so the light starts to fade fast. And you can actually see the moon's shadow rushing at you, which is really a neat thing to see. There's two special effects that happen in the seconds before totality. One is this diamond ring effect, where you have this last sliver of sunlight shining through, and then you can see this part of the band of the ring, and that's the sun's chromosphere, which is the sun's layer at the surface is called the photosphere, and then the next layer is called the chromosphere. So the photosphere is pretty much blocked out by the moon at this stage. And so you're able to get a look at the chromosphere. So this is spectacular to see. And then just before totality, like in the few seconds before totality, you have this phenomenon called Bailey's beads, where the moon covers the last sliver of the sun. And you can see just a little bit of the photosphere shining. And then you get this beaded effect when the moon is shining through lunar valleys on the leading edge of the moon. And I think it's so cool that they figured that out. And this is a diagram that was put together so you can see a correlation between peaks on the moon, where you can't really see much light coming through, and then in valleys on the moon, the light is coming through. So that's when you see one of the beads. So I thought that was pretty interesting, and that's been studied over and over. And okay, so once you do get to totality, you can start seeing really nice images of solar flares and prominences, and also you still do see some of the coronasphere, but you're beginning to see some of the sun's corona, which is the layer, the outer layer of the sun outside the chromosphere. So once you're in totality, you can safely observe that phase by taking off your solar glasses. You're not getting any more light than you would normally get like at a full moon. So it's safe during totality, but only during totality. So these solar prominences that you see here, these are jets of hot gas that are propelled by explosive releases in the sun's magnetic field. And if you have binoculars, you can use them without solar shields, and that will be able to help you see the chromosphere and the prominences better. Totality is just an unforgettable experience, and it truly is very moving. Everything gets really quiet and the winds die down, and birds actually stop singing, and other living things may get quiet and start settling in as if it were night. It's just amazing. Like I said before, you can get a temperature drop of 10 to 15 degrees, and the sky gets dark enough that actually you can see some planets and stars, and shadows become sharper. And we did experience this. The shadows become sharp enough that you can actually see the hair on your forearms on your shadow. It's just amazing. Some factors affect the length of totality. Okay, so one of the things is the shadow of the umbra moves at different speeds across the Earth's surface. So in this particular eclipse, they're saying the speed will range from about 1,300 miles per hour to about 2,200 miles per hour. And that depends on the local topography also. But these two lines represent the path of totality. And this red line here is the center line. And this yellow line is the northern extent of the path of totality. And this southern line is the southern extent. So of course, on the center line, you're going to see the maximum totality possible. But as you move towards the southern limit, your time of totality will decrease, and the same as if you move toward the northern limit. But it doesn't decrease by minutes, it just decreases by seconds. The longest period of totality is going to be down here in Mexico, actually in Mazatlan, Mexico. It's going to be 4 minutes and 28 seconds. In the US, once it gets into Texas, the totality is going to be over 4 minutes, all the way from Texas to Indiana. And after that point, the time of totality will start decreasing. Here's the planets that are predicted to be visible during the totality for this coming eclipse. And this is based on some modeling, but this is what the sun will look like when it's totally eclipsed. And then this is Jupiter up here. This is Venus down here. And this is Saturn down here. And there is a comet that's visible if you look at the night sky now with binoculars. And some astronomers are saying that you might be able to see it during totality. So I think it will be between the sun and Venus here. And it will be a green color. So try to look for, well, if you're in totality, you can try to look for that. But you'll be busy if you're in totality because there's just so much to take in. Like I said, you'll see strange colors in the sky and on the horizon. And your eyes are going to be able to see more colors than a camera could capture. And the sun's corona, its outer atmosphere, will be visible. So since I didn't have to protect my eyes during the time of totality, I purposely moved away from my technical camera because I wanted to have the experience. And so I shot a couple pictures using my point and shoot Nikon. And so this is one that I took with my point and shoot Nikon. We were really sweating the cloud cover, but we did actually get to see totality. Before then, it had been really clear, but just as totality was approaching, the clouds started coming in. But anyways, that's how it looks. It really does look like that. This is how it looks if you have a really good camera with a solar filter on it. the sun's totally blocked out and all you can see is the corona. And scientists always take advantage of a total solar eclipse to find out more about the corona, because you can't see that normally when you're looking at the sun. It's just overwhelmed by all the light that's coming out of the photosphere and coronosphere. So, or chromatosphere. Yeah.
You said that in totality, you guys are so humid to not use sunglasses, but that is only if you're in a place where it's a total eclipse.
That's right. Yes,
So here, we don't have. Correct?
that's correct. Yeah, I hope everybody heard that, and I'll say it again just for emphasis. If you're watching from here, you're only going to see a partial eclipse. And it's important for you, whenever you look at the sun during the eclipse, that you have your solar eclipse glasses on. If you're going to look at the sun, you cannot take your solar eclipse glasses off, because you can have serious damage to your retina, and you won't even know that it's happening until at least a few hours past the eclipse. So don't forget that. So the sun's corona is mysterious and it's beautiful. Here's two different shots of the corona from different eclipses. And you can see some of this plasma curling back on itself. It is hauntingly beautiful. And this is a quote from someone: "Without doubt, it's one of the most awesome sights in all of nature." And as I mentioned, the total eclipse gives scientists a chance to study the sun's corona, which actually extends about 5 million miles or more into space from the sun. And just to give you some perspective on that, the sun's about 93 million miles away from us. Okay, so Madeline, thank you for bringing up eye safety, because it's so critically important to make sure that your eyes are protected adequately during the entire partial eclipse phase. Otherwise, you'll risk immediate retinal damage and possible blindness. So if your eyes are damaged during the eclipse, chances are that you're going to have permanent damage. So these are what the solar eclipse glasses look like, and I held up a pair earlier. This is a camera that's fitted with a special solar filter. This is a pair of binoculars that are equipped with special solar filters for each lens. And this is a telescope that has a solar filter on the end. So if you're planning to use anything other than your eyes to look at the sun during the partial eclipse phases, you've got to have a filter on whatever device you're using in order to safely view it. Like when I photographed the eclipse in 2017, I had a special solar filter on my camera. And then I could look through my camera, because that solar filter not only protected the camera from the light, but it also protected my eyes. So don't think that you can just put on your solar eclipse glasses and use a pair of binoculars. It's not going to be good enough. You have to have solar filters on the lenses of the binoculars. So if you've got eclipse glasses that are the right thing, they're going to be able to filter out 100% of harmful ultraviolet and infrared rays, and almost 100% of the intense visible light. Your solar glasses need to conform to this ISO standard. And here's another reminder to always wear eclipse glasses when you can see any part of the sun. If you can't remember between totality and partial eclipse, just any time during the time of the eclipse, if you're going to look at the sun other than totality, have your glasses on. If you wear your glasses during totality, you won't be able to see anything. So I wanted to point out, as Karen mentioned, I went to the 2017 eclipse with some friends of mine, and their son was there and their grandkids were there too. And their mom had used a paper plate and inserted the eclipse glasses into the paper plate. So they made it so that their son would want to put that on, and it was a way that they could ensure that he'd be having his eclipse glasses on anytime he looked at the sun. So if any of you are grandparents, you might want to do something like that for your grandkids. Here's another indirect way to look at the sun during the eclipse. It provides a sharp image of the sun. And one of the nice things about it is that other people can look at it too. So if there's a group of people that are going to look at the eclipse with you, you can buy one of these. They cost around $430, but if you get kids looking at this, it's another way to ensure that they're not going to be looking at the sun. And the way it works is the sun's rays come through a hole in the board, and then they project onto a piece of paper, and you can get an image of the sun at whatever phase of the eclipse that it's in. This is before it starts or after it's finished, and this is like maybe 75% approaching totality. But what's cool is you can have people in your group chase the outline of the sun at the time, and you can put the time on it. And as many people that want to trace it can, at each stage. And so it gives a nice visual record of the eclipse. So what's the partial eclipse going to be like in our area? So these are times for Washington, D.C., but our times are going to vary from this by no more than a minute. It's probably more like seconds. And these times are on the handout that's over on the table. So the eclipse is going to start at 2:04. It's going to reach its maximum partial eclipse. 89% of the sun's surface will be covered at 3:20, and then it's going to end at 4:33. So I have some suggestions for you. One is, if you don't have eclipse glasses, you can grab some of these pairs up here. But if you need to order some and order any sun filters for other equipment that you have, like binoculars or cameras, here's a website that you can go to. Another suggestion is to make a plan B, because if it turns out that it's cloudy at the place you're originally planning to watch the eclipse, you want to be prepared to move somewhere else. You don't want to be standing at your first site thinking, oh, where should I go now? You probably want to know where to go next and be ready to get there. And that's if you have clouds or bad weather at your original viewing site. Maybe you can get out of that area within a reasonable period of time and get to a place where it's clear. If you're going somewhere to observe totality, my advice is to be present. And by that, I mean, be really focused on experiencing totality. It's very short, like 4 minutes or 4 minutes and 28 seconds if you go to Mazatlan, but that's a long way to go. Just the bottom line is, don't let yourself be distracted by anything. Like I mentioned, I just walked away from my technical camera stuff. You don't want to miss totality while you're fiddling around with your camera or with anything else. These are some suggested websites, and I have these on the handout on the table over there. I split them out into just general information about this eclipse. Then there's a section on eye safety and a section where you can find out eclipse weather. These are websites under the weather. They're totally focused on weather for the eclipse. Gary.
There's also a site that has a lot of other stuff on it, but it's called timeanddate.com, easy to remember. And if you go there and scroll down, you'll find a link to the eclipse coverage, and you can actually put, in my case, Riva, Virginia, in there, and it will give you the times and a simulator where you can slide back and forth and see the different phases of the eclipse.
Wow.
So it's really great.
Yeah.
It's a Norwegian website.
Wow.
Just really cool. And it's in English. It's not in Norwegian. What was the title like it was there? Timeanddate.com. It's got a lot of other stuff on it about times and time zones and but it has complete coverage of the eclipse with shadow path and all of that.
Wow. That's great. I'll have to check that out. So I hope that you enjoy this experience of a lifetime, and I wish you good weather wherever you are for the eclipse.